Alright, in the last video we took a look at the introduction of conjunctions, and I showed you how to combine them to write them. Now let's take a look at how to solve a pair of conjunctions. Remember, conjunctions are two inequalities connected by the word and. So it's, in this case, your 7x plus 7 is greater than or equal to 7, and 7x plus 7, the same expression, is less than or equal to 14. So two separate inequalities combined into one. When solving, we're solving two inequalities at the same time. We have the skills to connect this inequality on the left. We also have the skills to solve the inequality on the right. So we could either solve them individually or simply combine the two and realize that you're doing three things all at once. We'll take a look at how to solve this specific example on the next slide. So here we are. Example 12 happens to be the number out of our book, but we're going to look at solving the same inequality. 7 is less than or equal to 7x minus 7, and less than or equal to 14. So solving this, as always, you want to get x by itself. So we're going to have to eliminate the coefficient of 7, as well as the constant of negative 7. When solving, we get rid of the constant first where possible. In this case, it says minus 7. We need to actually add 7, because it's the opposite, to all three sides. The left, the middle, and the right in this case. So 7 plus 7 is 14, less than or equal to 7x, less than or equal to 21. Make sure you rewrite it every time. Okay, all that's left to do now is divide by our 7 in the middle. It says multiply, the opposite of multiply. Divide all three parts. So rewriting the left, 14 divided by 7 is going to be 2. In the middle, 7 divided to give you 1, so it's just x. On the right, 21 divided by 7 is 3. So our inequality arrows do not change. We simply rewrite this as 2 is less than or equal to x, which is less than or equal to 3. X is in the middle. I have two conjoined inequalities. In most cases, I want to be sure that my students have the ability to graph the inequality. A visual representation helps to the understanding of the situation. So if we take a look at our number line, our two numbers of interest are 2 and 3. We're going to have closed shaded in dots because we are equal to. Remember, the dot means this value will work if you plug it in. X lives in between, so I'm going to shade in between. If x is bigger than 2, that would be to the right. X is smaller than 3, that would be to the left. The common area is directly in between the two. If I asked you to write it in set notation, remember, that says the numbers from 2 to 3. Question my students typically ask at that point is, do I use a parenthesis or a bracket? Parentheses are associated with the open dot, or inequalities without the equal to arrow. The bracket is associated with the closed dot, or equal to. So since we have closed dot and equal to, our set notation would be all values from 2 to 3. Brackets mean they are inclusive. Let's go ahead and try another example. Problem 13 up over here says negative 5 is less than or equal to 9t plus 4, and that is also less than or equal to 22. So following our last steps, I got rid of the constant first, doing the opposite sign. In this case, that means subtract 4 from all three parts, left, middle, and right. Rewrite it. Negative 5 minus 4. When doing addition, that's adding and subtracting. Same sign, says you add them. And I have negative still. Less than or equal to. 9t remains in the middle. Less than or equal to. 22 minus 4 is 18. One more step. T is multiplied by 9. Opposite of multiply would be divide. So I divide all parts of this inequality by 9. Negative 9 divided by 9 is negative 1. Less than or equal to. T, the variable, less than or equal to 2. Inequality is solved just like that. So the solving process is just like that of an equation. In this case, I just created another side of the inequality to be thought about. Alright, graphing one more time. My numbers of interest are negative 1, positive 2. Equal sign, so again it's going to be a closed dot for each. t is directly in between them. They are connected. Set notation, -1 to 2. Closed dot means it will be a bracket. So all values between -1 and 2 will make this given inequality true. And there you have it, solving compound inequalities. Once again, just like solving any other equation, the main difference is you've got two sides to think about now. So multiple pieces to consider. However, your solving process using the opposites and doing the same to all sides, that all remains the same. All I'm adding here is the additional step of graphing and the idea of set notation. Just remember that the parenthesis is associated with the open dot, or strict inequality, no equal signs. And the bracket is associated with the closed dot, which means an equal sign does work. Next video, we'll take a look at how to work with disjunctions.